Okay, in this short video, I want to tell you about strings. We're going to be using them quite a bit during the course, so I should give you just the very basics. So we are all on the same page. So here are the definitions. So let A be any set, a set of whatever you want. You can think of the elements as symbols, but whatever set you want. So first, we define A to the n, the nth power of A, is a set of n tuples from A, n tuples of elements from A. So this guy up here is what we call an n tuple. It has n elements from A, one after each other. For example, suppose that we have a set with 3 elements, what we call A, B, and C. A to the 0 consists of only one tuple and is the empty tuple. So this symbol up here means the empty tuple. Alright, so it's a tuple with no elements inside. A to the 1 contains the tuples which each of which has one element. So this guy up here is a tuple with one element, A. So it's a string with one element. If you consider A to the 2, now we get a bunch of tuples, 9 to be more precise, and the tuples that we get are A, B, A, C, you get the idea. All the pairs of elements from A, and so on and so forth. So in logic, we use the symbol A to the less than omega, this is an omega, to denote the set of all strings. So this is the union of all strings. So the 0 tuples, the 1 tuples, the 2 tuples, the 3 tuples, all of these guys up here, all of them together make the set of strings of elements from A. We will sometimes omit the symbols left bracket and right bracket and just write and omit the commas and just write, for instance, Kabaka instead of C-A-B-A-C-A. It's just easier to visualize. I mean, it will depend on the symbols. If these are numbers, we won't do it, but if these are letters, we'll do this often. For instance, if A is the whole alphabet, the whole English alphabet, Roman alphabet, then every English word is going to be a member of A to the less than omega. So it's going to be a string. Every word is going to be a string. There are going to be strings that are not words, like kabaka, for instance. I guess it's not a word. But in particular, the words are going to be strings. One last definition. We use these 2 bars to denote the length of a string. So if sigma is a string, this represents the length of the string. So for instance, meaning the number of elements of the string. Alright, that's it for today. Next time we'll start with propositional logic.